All right, we'll start with number 81. So here we have a more complicated circuit than you had in 79. In 79, you just looked at your total voltage and then divided it by total resistance. Here, this requires a little more thinking. So we have two rules, Kirchhoff's rules. There's a loopy and there's a junction rule. So first of all, let's look at what we have here. We have current of 3 amps going through 4 ohm resistor, which means that potential difference on here is going to be 12 volts. And if you look at how they are connected, 4 and 8 are in series, so therefore 8 ohms is also going to get 3 amps, which will mean that 24 volts is going to be the potential difference across it. So we lose 24 volts over here and we lose 12 volts over here. So if we took say if I connected a voltmeter over here across this resistor, it would show me 12 volts. And if I connected a voltmeter over here, it would show me 24 volts. So that's our potential difference. Added together would be 36 volts. So we're losing 36 volts over here. So let's say I'm going to suggest that my loop is going this way. Then, in this case, I have a potential drop of 12, then a potential drop of 24, and then I have a potential rise of only 24, which doesn't make sense because I will have 24 over here lost just by itself. So where will potential difference for these two guys come from? You will have more drops than rises. So this right here, this does not make sense. This loop does not make sense. So let's look at a different loop. What if our loop goes right here? Well, if I'm saying that my current goes like this, then I'm saying that this battery is less powerful than this one, because look at this. This battery is getting current to go through the resistor, go through the battery against the natural way, right? And then like that. Because naturally inside the battery, my current is going this way. And this one is pushing it against the battery. So this is more powerful than that one. And then, so if this loop works, and then there's got to be another loop, and that other loop is going to be the very outside one. So this right here, again, this does not work for us. It does not make sense. So this right here is not the loop. It does not work. This works, and then that is your second loop, the outside loop. So in the outside loop, it will work that way if, well, it will work anyway. So if you look at here, my current starts over there, then part of it goes through this, and part of it goes through this junction. So these are the two established loops that work for us. So now we're going to apply Kirchhoff's rules. So the junction rule, look at these, point A and point B. Where will we have more current coming in and coming out? So we have the current coming into A, definitely, right? From here. And then current goes out, right? And then in B, we have this current coming in, and going out, right? So we have, so the current starts over here, comes into A, splits, goes out, and then comes into B, comes together and comes out, right? So then we're going to lose the loop rules. The loop rules, so that's the junction rule. We have coming in, coming out, coming in, coming out. And the loop rules are 6 coming. So looking at the outside one, we have 12 volts lost over here, 24 volts lost over here. Then we have current going through 2. So that's going to be potential difference 2 times that current. And then all that should be equal to the rise. And that rise is going to be this potential difference across this battery. So the terminal voltage of that battery. That's our question mark. So that's for the outer loop. The inner loop, the smaller one, we have 24 as our drop. Then we have a drop of 2 times I going through this. That's your second drop. Then you have, that's a rise, and then we also have another drop of 6. So again, this right here is our rise, and those are all drops. So these are drops. Oh, I'm just going to do drop. And this also is a drop. So from here, if I add these two, or subtract these two rather, if I subtract, well, first of all, I'm going to say that these guys are equal each other. So this side equals this side, and then this goes away. And so this is 36. That's 24. Also can go. So you have 12 volts equals 6 times current through 6. So that means that this current right here through 6 is 2 amps. So then we're going to see that we have 3 came out and 2 came out. So this right here is 2 amps, which means that this current right here was 5, and which means that 5 amps will come out of B and go through 2 ohms. So there you go. And then having this current right here, I can either use this equation or that equation, and either way I will get 46 volts.